Hello everyone, welcome to Maths Easy. Here's another GCSE exam style questions on moments. It's a very popular exam question, moments and to do with moments, especially in triple papers. You can get it in combined as well, but triple science, it's very common. Here's a typical exam style question. Pause the video and give it a try. And when you're ready for the answer, press play. A uniform beam. Now in physics, when they say a uniform beam, that means the weight is evenly distributed. So like the center of mass is right in the middle. So like the weight acting from the center, that's what it means. Of length 2 meters here and weight 200 newtons. Here 200 N. Is supported horizontally at 2 points, a pivot at one end point. End A. So let's call this I, and here we have a pivot and a support 0.5 meters from the other end point B. So here this is point B. There is a support, but the support is half a meter away from here. So this distance here is 0.5 meters. So what I'm doing here, I read the question and I just extract all the information onto a nice diagram so I can analyze it. A 300 Newton weight is hung 0.75 meters from point A. Okay, so this is point A and there is a 300 Newton weight. Now because I know this is 2 meters, so this weight 200 is acting exactly at 1 meter. Why? Because it's a uniform beam. Now this is at 0.75 meters, so I know it's kind of about the 3/4 of the way. And that is 300 newtons. And I'm going to mark this distance as 0.75 meters from the end. Okay, got that. Calculate the moment about point A due to the 300 Newton weight. Oh, that's actually pretty easy because the moment is force multiplied by perpendicular distance. And 300 newtons is the force and the perpendicular distance is 0.75. So all you need to do is just multiply 300 by 0.75 and that gives me 225. Now it's a moment, so measured in Newton meters. So answer for part A is 225 Newton meters. This is in a clockwise direction. You can just say it like that. Part B. The beam is in equilibrium. Calculate the upward force provided by the support at point B. Okay, there is an upward force here. Let's call this one R for reaction. R. Now let's think about equilibrium. Now, the principle of moment says for equilibrium, the sum of clockwise moments is equal to the sum of anticlockwise moments. Now, let's have a look at it. If you think about point A and you take moments about point A, we need to specify the point or the pivot around which we do that. So this is point A. Now I can see this is clockwise. 200 newtons also create a clockwise moment, those two. However, this force R creates an anti-clockwise moment. Now, sum of clockwise moments. So the first one is 300 multiplied by 0.75. That's the clockwise moment created by the first force. What about the second force? You need to add 200 multiplied by, now I know, because this is a 2 meter beam, the weight is acting from the center, so that will be a meter. So 200 times 1 is equal to anticlockwise. I don't know the force, let's call it R times by the distance. Now, this bit here from the end is half a meter. So I need to get the distance from the point, from the pivot, from point A. Now I know that distance is obviously 1.5. Why is it 1.5? Because 2 take away 0.5. So I know this distance here all the way up to here must be 1.5. So r multiplied by 1.5. Let's simplify this. I already know 300 times 0.75 is 225. So that's 225. Add 200 times 1 is just 200 is equal to 1.5 r. 225 plus 200 is 425 is equal to 1.5 r. Now just divide both sides by 1.5. So I can cross these two out. So I can find the value of r as 425 divided by 1.5 gives me 283.3 recurring newtons. Here's the answer for the last part, part C. Explain why the weight of the beam acts at a particular point and how this affects the calculation in part B. Now, the beam is uniform, meaning the weight is distributed evenly. So the weight acts at the center. So that will be a meter from each end. Now, why is it important? Because it creates a clockwise moment that must be balanced by the force R at the other end. So we can write this as the answer for the last part.